Here's another example, more example. I have a square here, a 1 by 1, and I divide it by half, get 1/2, and I divide the half by 2, so it's 1/4, and this is another 1/4, but the 1/4 I divided by 2, get 1/8, and you keep adding all those terms, they add up to 1. So we know then that the sum is 1 of all those terms, infinite terms. Now we can rewrite it as 1/2, 1/2 to the second, 1/2 to the third, and so on, with the nth term 1/2 to the n. Now in sigma notation is the sigma from 1 to infinity, or 1/2 to the nth term. And we already know it converges, but let's show it from the way we've been doing it. Notice that this one can be written as this, and this sigma notation of this series is geometric. So it is geometric with the r equals 1/2. So since r is less than 1, the absolute value, then means that it converges. So it must have a sum. So we use the formula a sub 1, which is the first term. We already know what the first term is, 1/2. And the ratio, we already know also is 1/2. Look, it's right here, 1/2. So when we do the calculation, we get 1. So which basically is the square y 1 by 1. That's a neat way to show from a concrete point of view to the mathematical point of view. Now, the majority of the series, you won't be able to find the sum. As a matter of fact, there are some you won't be able to find it at all. They haven't found it. They know they converge, but they don't know what the answer is, or the sum. Some of them are the complexity to find it is quite high. But the ones that you can find the sum, and usually what they ask about finding the sum are the geometric and the telescoping. All right, so that's these two, geometry and telescope, usually what the questions are. All right, see you next.